Oh, hello. It's been a while, but here we are again. Hello, Nigel. Hello, Nertzl. We're going to work on cast. Minicast grew up. Cannot call it mini now. Well, not yet. Not yet. I have not really done much yet. But yes, so the plan is I'm going to convert minicast. Thank you for the jump scare. I'm going to convert minicast to cast, and that is the plan. That's what we're going to do. Also, since the last stream, thank you for the prime, Bigorly.
Thanks for the ping, Nigel.
Naruto doesn't have a hello.
Well, technically it was Could Be Bought who pinged you. Not Nigel. Yeah, I was just we have Discord that is dedicated to the casting now, so if you're interested in following cast, you can join there. Well, everyone who's on stream right now is already there, but I'm just going to add this to my bottom section. All right. And we're converting minicast to full cast. That is right. That is right. Okay, last time I was doing the Lisp Jam. The Spring Lisp Jam 2026. But I did not do anything. It looks like some other people did. Did you do the game? Oh, you look at this. Nigel. Parentheses drive me crazy. Let's check this game before I start on the thing. Made enclosure script targeting JavaScript with Canvas API using Shadow CLJS. Project source code instructions. Parentheses drive me crazy. How to play? Okay, how to figure out how to play, Nigel? I'm clicking how to play. It doesn't tell me. I guess I cannot click start either. This happens with fancy cursors. Is my cursor fancy? Oh, I just realized. Yeah. You know what? Like this is yeah. Um, I think the reason you don't see my cursor actually is because I disabled it in the Hyperland. Can I just enable it? Hyperland. I will need to like convert my Hyperland to the Lua also at some point, I imagine. I think it's hardware cursor. No? I don't know. Hopefully it's not too annoying that you don't see the cursor, whatever. So I cannot play the game? At all? Should I use a different browser maybe? I mean, what is the JavaScript API that you use to figure out the mouse position? Hold on a second. Pointer down. Yeah, I don't know. It's supposed to work. Maybe there is some errors in the console. I don't see any errors in the console. Well, I mean, you do draw this circle as you, like, I'm imagining you are the one who is doing this circle that is drawn, right? So, yeah. Responsive design mode, maybe? No, that doesn't work either. Well, can I full screen? Well, I mean, yeah. Like this. This is full screen now. I don't know. Can anyone else check? Nerdsoul maybe? Is Nerdsoul here? Can you like check that you can click on this thing here? Is it my problem? For some reason? That'll be weird. Infinite Coder played on stream? Maybe it's a Hyperland issue, but like why would that be the problem? Let's take a look at the source code. Where's the menu? Is it in the game? Is it in the main? You cannot click it either? Okay, so there's something wrong. Like I imagine listener. Listen to pointer down and pointer up events to maintain the position at which the mouse was clicked. Pointer. Okay, and then you do JavaScript add event listener. Okay. What do you add the listener to though? Isn't this supposed to have the event target too? Canvas? Because that's the state that you refer to or whatever? I don't know. It's a global console window. What if we try to open this in outside of the iframe? You know? Just as is. Then I can click it, right? So like it's embedded weirdly in the itch as an iframe. There's something wrong with it. Okay. And then I can oh, wait, what am I supposed to do? Hold on. Can I lose? I want to see the instructions again. How to play incomplete S expressions will show up by your steering wheel. Complete them by switching gears corresponding to the parentheses needed. To complete them by switching gears corresponding to the parentheses needed to complete the S expression. Oh, I see. Start. Okay, so this gear is the closing square bracket. So what if I just do this? Nothing is going to happen. So I have to move it over there. Okay, got it. Got it. Got it. Got it. A very interesting idea. This one is impossible. Oh, I mean, or is like this on the bottom one the one is actually going to be used? No. Is that what you imagine when writing Lisps? Yeah, I guess. I didn't read the instructions. Wait, what? I did! The game will get a little more difficult every 10 levels. The game will save automatically after passing a level. Click on the gear to rotate the parentheses on each gear. Click on a gear. Use the reverse gear to go back one parenthesis. Reverse gear. What's the reverse gear? Which one is reverse? The R. Oh, I see. Wait a second. What if I just reverse everything? I see. Now you can solve everything. Yeah. Got it. Got it. Like over here. Wait, we can rotate. I can click on the gear. How do I click on the gear to rotate? What is the gear? They said rotate parentheses by clicking on the gear. That makes no sense. The white circle. Where is the white circle? I don't see a white circle. I mean, you mean this thing? That doesn't look like a gear. I'm clicking on it, nothing is rotating. Oh, actually things are rotating. I see. They actually are rotating. are 40 levels, you say? And what level am I on right now? Mm-hmm. It says when you complete level 14. Okay, yeah, I don't know. I don't think I'm going to complete all the 40 levels, but this is a game, I guess. Very interesting. Did you enjoy the Lisp? All right, so here we are. We are going to convert minicast to a full cast. What this means is that the original plan was to transpile cast to minicast, and minicast would be like the intermediate language, but maybe this actually does not make much sense unless I want to like transpile the bootstrap to the current version of the self-hosted language, which is currently called minicast, but it's just not going to be called the minicast anymore. By the way, you were playing Link Slider today. You thought that there are not enough particles. Hello, Hisoka. Not enough particles. Maybe. Maybe you're right. More particles. I'll write that down. Hold on. Next time, whenever that's going to be. When I'm going to work on Linksider. I'm going to add particles. How do you do this? Plan, work items, new item, add particles, more particles. Nerdsoul said we need more. When you solved the problem and managed to click, how did you fix it? I opened it outside of each page and opened the like the HTML build directly without it being inside of an iframe. That's how I fixed the clicking. Will you get the credits for that? I'll think about it. All right. Okay. So here is the what minicast looks like right now, right? So here's a trip, for example. And the biggest change that I have to do is basically we are going to convert it into an interpreter, and the interpreter is going to interpret this line. So basically this over here is an expression that constructs the function at compile time, because we have the interpreter that's running at compile time, right? And stores it in a constant. Right? So once again, this function is literally just going to be a regular lambda that we created compile time interpreter instead. And then we are not going to have a main at all, I guess. So instead of having a main function, we'll literally just say that this over here is our code, right? Or if we really want to have the main, we could still keep the main and then say that we just call main directly. Is this Python? Yes. Well, I mean, no, it is cast, right? Okay, so I think we start with that, and then later we'll add the macro, so finally I can stop doing this annoying looping, and we can actually use a for loop, which is going to be implemented using macros. Yeah, we don't even need much features in the interpreter right now. If name is main, I actually think that we need something like that, and but I was thinking, like, yeah, I think, yeah, it does make sense to have something like that, actually. It does. Minicast is written in cast, yes. Yes. I was thinking, like, I mean, maybe sometimes it makes sense to like just run the file as a binary directly, right? But I think what makes more sense is to like write tests in this way, right? Because because we have the interpreter running at compile time, we can say that if we want to run tests, then we just interpret this code too, right? So something like if name is test, then we just run some tests. You know, I was thinking something like that. It's probably not name is test, but you know, yeah. And this is like at compile time, whatever, like eval if like something. I don't know, because I don't have the dedicated for the compile time if. Whatever. That's not what I want to think about right now. What I want is just to change the minicast into the interpreter. So now, like right now, the result of compiling a minicast program is a program which contains types, which contains contexts, constants, and functions. And one of the main functions is going to be main, and that's it, right? And now what we're going to have instead is going to be just like in the cast itself. When we compile, we're going to compile a single file now. Right now I'm compiling like multiple files, and like the order kind of doesn't matter, I guess. But now we're going to actually compile like a single file, and the result of compilation is just an expression. And that expression is what goes into like the main function of the C code as a result, I guess. That's what we want. That's how it works in cast. What also this is going to give us is the automatic tree shaking, so to speak, where we eliminate that code. The code that is not used at runtime is not even going to be generated, right? Yeah. So there is no such thing as a program anymore. We already have the expression. We already have expression. And so this is literally just the result of the thing. Okay. So we get rid of the program altogether. I think everything else is basically staying. Okay. So now, Lucas develops with a raid guided by Penguin, it seems. Hello, hello. How are you doing? Are you also making a language or something? No, a game? Oh, okay. Null Giraffe. Hello, hello. Vulcan and Zig making a game. Nice. What's the game about? And how far are you into making the game? We like making games. That's the goal of the language that I'm making. I'm working on the programming language here, and I'm going to be making games with it. And I have been making games with it already, but it's small games for game jams for now. Just a couple small ones that I've made. Heard this stream is actually about game dev? Yes, we're going to get there. Trust. We are. So since you're using Zig, one of the things that I'm going to be working on right now, actually, is making the language to be interpreted at compile time in order to be able to run compile time evaluation. This is already the thing that is happening in the Bootstrap. I'm working on self-hosting, and right now I have a smaller version of the language with not all of the features, which was more closer to the classic C, and we're going to turn that into the thing with comp time and stuff. How did my attempt at Lisp end? I did not work on that anymore because I was busy doing other things. So we just dropped the Lisp. Gem altogether. Kind of like Risk of Rain 2, you got Steamworks multiplayer, the renderer, working GLTF loading, and animations physics with Jolt. Nice. Nice. You're writing all of that from scratch? Or just use Vulkan? That's the only thing that you do? And like GLTF, do you parse GLTF yourself without using any libraries? Well, Jolt, I guess, is the library, right? Jolt physics. Okay, so we are working with two things at the same time. This over here on the screen right now is the cast, which is the language that I am making, and then using that language, we have been writing the mini cast, which currently looks as this. And yeah, so like the way this has been working is that we have like top level functions like this, and we were using the syntax like const, the name of the function, and then this looks like a lambda, right? But in reality, this was like parsed as a top level function, but it is actually supposed to be a const of any type, and this value would be a lambda, which we evaluate at compile time. That's how it's supposed to work. So that's what I'm going to be doing now. So we need to evaluate the definition of a lambda at compile time, and then convert that later when we so like the compilation process is like a two-step compilation. We first compile the thing to the intermediate representation, during which I can invoke compile time evaluation and stuff, and then so like the result of me compiling this file, for example, because everything is a const, right? So this actually doesn't generate anything into the intermediate representation, I guess. So there is only a single expression here, which is supposed to be the call of the main function, right? And so, but then when we see the expression which is using a constant, it means that that constant needs to be included in the final binary, right? So we see that this is a function, so then that's what triggers the compilation of this function actually into the target platform. All right, so yeah, I'm just going to be changing the way it was working, the compiler here. So we were having a thing called top level item, but I actually don't want to have that at all. This is going to be a big change. This is going to be a big change. And we don't have a thing called program anymore, because the result of compilation is just the expression. Okay. Yes, so we have the compiler, right? This is my compiler state. We don't have top level items. We don't have this. Let's just start with an empty state of the compiler. We'll add things as needed, right? But in order to be able to evaluate things at compile time, one of the things that the compiler needs to have is the interpreter. Okay, so we need to add the interpreter actually. Yeah, let's do that. Interpreter. So the compiler, it depends on the interpreter. Yeah, that makes sense. Dun, dun. Pum, 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 pum. Okay, and how do I do this? I have a more channel. It's a little weird right now, but this is basically very similar to Zig. We define a struct which acts as a module. Module keyword is literally the struct keyword from Zig. When you will start working on the AAA game with Cast? Never. Never. So it's not the interpreter. The interpreter state, I guess. So we're going to have the interpreter state. Yes. Okay. And I need to be able to initialize. The interpreter. Bum, 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 bum. So when I initialize the compiler, we also initialize the interpreter. So all of this, get top level impl, get top level declaration, all of this stuff is actually, yeah, I don't know. Do I just delete all this code and write it all from scratch? It's going to be very different. Let's say the general, right? Like, so what we do is we just say compile. And we're oh yeah, but I was doing the add source. Yeah, so like the way it was used before the minicast compiler is that we give it the list of sources, and all of those are being compiled into the program. But that's not the case anymore. We'll have to add like explicit imports and stuff, I guess. Or includes. I guess the like the most important one is being able to have the recursive scopes. Right, so yeah, because previously what happened is like I was I was first seeing all the top level items and what their names are, and then after I know all the names, I was processing them one by one, right? But now we need to process the things kind of immediately. So the cast compiler was done like that, but sometimes you need to await for the thing to be defined for having recursion, right? So for that we generate, we have recursive scopes, and whenever we look up a name in the scope, we potentially stop whatever we're doing and allow the further processing of the scope, basically. So like when I start compiling a function, for example, right, we fork that into a separate like coroutine, the compilation process of a function, and if the function compilation process requires access to something that is not defined yet, then we need to wait, and that leads to the async compilation model, basically. I was also thinking that instead of it being async, maybe we do the same stuff that I don't know, like that Zig is actually doing, which is instead a lazy compilation model, right, where things are only compiled when they are actually needed. which also means that they are not compiled if they are never used, and they're never checked for errors. If that's the case. Hmm. We'll see what I do here, because like I think in the Bootstrap I don't have the way to do async stuff actually. I did the delete continuations to minicast, but not to cast. Okay, but in general, we don't add sources and we don't compile. We literally just compile. We literally, so like the API is something like this. Compile source. Right? So when I compile the source, I give it the state of the compiler. And I take the source and I return the expression. So the result of compiling source is the expression, right? That is all. So first thing that we do is we parse the source, right? And then we compile st. Well, we don't even like, I don't even need to say compile AST. Because this is what it's called, right? I mean, technically it's called parse expression, right? Yeah, what is the expected type of it? Do we want... Yeah, let's see, compile AST. AST. Let's turn expression. So I'll need to set up some of these things for sure. So one of the things that we were doing is the compile time scope, which I will still need to do. Which I guess now actually lives in the compiler state itself. Parse top level item. We get rid of that. Add top level item. I get rid of that. Process top level item. Enum union opaque type. Yeah. It's not going to be that easy to make this change. With the root scope compiler. Lookup type, parse type. Oh, I see. Yeah, let's, you know what, let's not worry about this. So what, so we are going to be able to compile source into the expression, right? And compile AST. into an expression, which is just going to parse expression. So we like, instead of explicit state passing, we use the context system here. Is Minicast now on track to be a self-hosted cast? Yes, that's the plan. That is the plan. Minicast has a couple of features which Cast doesn't have, but I mean, we just keep them, I think. For example, the Minicast has like unions, and yeah, I guess it's just like the union, I guess, which is different from the some types, the AGTs in Cast. Delete discontinuations that I added recently, and templates instead of generics. News came. News about Close to Light. Tiny update. There's a small update introducing new accessibility feature. Making telegraph brightness configurable by and lower by default. Damn. In other news, there has been lots of work done on the level editor, and it is now available in still better bridges for early testing. See the no access channel. No access. You don't have access to this link. Urzel, you put the link and you don't even get a mapper. I see. Okay. I see these lines. I know where you took these horizontal lines on the post-processing from. Look familiar. So we just parsed expression. What is the expected type? I guess like we don't expect anything. Right? I think we just don't expect anything. Like if I try to compile the code which returns an integer instead of a unit, what does that mean? Well, I guess that could be discarded later. If we want to. But if I write like evaluate a file using the interpreter, then that would be fine. First question, non-AST. Okay. And that's what I return. That is it, literally. I just set up the context. And parse expression with non being the expected type. I need to set up the scope context. So what's the scope? I think scope is state global scope, basically, is what I'm going to create a global scope in the compiler. Right? Template args context. We'll see how these things work. So we no longer have top level items. Here's what we had before. We had templates, types, constants, native const, function, and context. We don't have that anymore. Const declaration, parsed expression, template, instantiation, template name, template args, name. What's the template name here? Template arguments is the list of types. I guess like also since I'm doing that, we'll be able to switch from just the type arguments to any kind of arguments there. Compilation target, C JavaScript, type kind. I think type kind is not used at all. So, and this is just forward declaring what a compiler is able to do. So we don't have the program anymore, but we should be able to parse expression. We should be able to parse a type. Well, this is interesting. Well, I mean, we can start with without making types being treated as values, right? Yeah, let's start with like the minimum changes. Find identifier type. A lookup type. Yeah. So like we will still syntactically know if we're in the type position or in the value position for now. So this is fine. So this is looking up the value and this is looking up the type. There's not going to be a thing called add top level item anymore. Do I get rid of templates for now too? Template args context. That thing is not going to exist at all. Okay, this can be removed. Okay, so when I'm... Yeah, I don't need to print the program because there is no such thing as program anymore. const declaration, when I process a const, it's going to be done differently. Completely differently. Is this even needed? I think this is not even needed. Const. All right. Get top level declaration, right? So right now, when I'm trying to find the identifier type, I'm trying to find it in scope, but if I don't find it in scope, then it is the top level thing, basically, right? So there was a distinction like that, and now the distinction is just not going to be there, because when I try to find the name, actually, here's what the context at compile time, I mean, what the scope at compile time is. Where is it defined? Scope. Over here, right? So the scope is defined as this thing where we have the variables, which is just a map from the name of the variable to the type. But that's not actually the thing. I think we can call this locals in this scope, and this is going to be a local, and a local is going to be either it's either a binding or it is a constant, right? So it's either a thing that is known at compile time, or it is a run. It's either a runtime or a compile time variable, basically, right? So a constant is a compile time value, in which case we just literally store the value there, right? So now we have this thing called values, and binding is going to be a binding going to have the type inside. What's the type of this thing? We're going to have other things too, but yeah. So if I have the value, then I know what the type of the value is, right? You have the binding, I know what the type of the binding is. So when I find in scope, I'm going to find the local instead of the binding. So but when I want to find the type, yeah, so we just literally just report that the thing is not found in the current scope if it is not found, but if it is found, then it is some local, and we're going to return local type local. If it's a binding, it's binding type, and if it's a const value, then this should be like value type of the value. should return like reference. Yeah. Yeah, and over here it returns a reference on local. We return the local. Not vars, locals is what I call it. Found in parent. Found in parent. Found in parent is the callback which we use to figure out if I am capturing a thing from a closure, which is only actually capturing if it's a binding and not a const, right? What is the type for? Well, I mean the type needs to be used because yeah, we need to know what's the type there too. Yeah. Let's for now just say that if so if result is some result, and then I say if result is the binding, right? And then I'm going to say that it's found in the parent. Not sure if I need to like look at whether I'm capturing constants. So it's binding type. Just going to keep this interface the same for now, at least. All right, so what is value, right? I need to specify what a value is. Do I specify everything here in the types, right? I kind of need to, because values can be types and types can contain values. This is like a recursive thing. Eventually. So let's see, value is, we're going to have the distinction, like we're going to have value shape, value shape. So what are the values that I actually need? Technically, I think all that I need right now is the top level function, right? So we have a function definition here, right? That is a compiled function already. So we can say that one of the values that we have is a function, and this is its definition. Which, yeah, I don't know. Let's start with that. do I store the type inside of a value? Or I can infer the type based on the value. Well, later we will have uninferred values anyway. So we're just going to have type. Is a type. That's the type of this value. Okay. All right, so this is going to be IR value, I guess is what we call it. No implementation of yeah, so this is literally just going to be value type, right? Yeah. Now let's have the let's have this going through the getter, because this might change. Okay, so now over here, I'm trying to compile a function, for example, right? Over here, I'm parsing a function, and we have the parent scope, which is optional, but it actually should never be optional. It literally is never going to be optional anymore, because we always have the top level scope. So I don't even need that. This is just the definition of the function. Parent scope. So we don't have parent scope is literally just current scope context. Some. It's a little weird, but yeah, something like that is what I want. So when we process the top level function, that's not even a thing that I need to do. So now the scope is supposed to have the locals, which is a map from string to a scope local, but over here we're making scope vars instead. Right, so we need to say locals. I need to say locals and to add to it. So these are the arguments of the function. Those are going to be the bindings. So argument binding, this is supposed to be a binding, which has the type. Like so. So for the name, we add the argument binding. Binding. And now we just parse the expression of the body. And that's it. All right. Seems like function is compiling at least. Now the template instantiation. So what happens when I instantiate a thing? So instantiation is like it was done by using the template name. So I was giving it the name of the top level definition, which corresponds to a template. But now that is no longer like the case. We will be able to like have local templates and everything. As a result. Of the changes here. So I think what I should do is instantiate should literally take the template, not a template name. And there is no such thing as find template anymore. Because this is like, yeah, this is getting top level implementation and everything. We don't have that anymore. It's not needed. But this returned a mutable reference to the template. So that's what we have. The template is the argument to instantiation. To instantiation the type, and yeah. So we don't need to find the template anymore. Calculating template args. Down, down. And we do instantiate. Get or init in the instantiations. Yeah. Just the template name here is still needed, right? It's because, yeah, over here I'm creating a name. Yeah, because I'm creating a new top level item, but instantiating. Okay. This is actually, yeah, we have the instantiation, right? It was previously when I was doing the templates, right? Instantiation means that I'm creating a new top level item, but now, because this is going to be an interpreter instead, we are just creating a new value. That's all. Or a reference to an existing value. Instantiation. So I don't have the template name. I think I just have the reference to the template here. Which was used to create this instantiation. The template arguments that were used to create this instantiation, and not the name, but the result is just going to be a value. Yep. The template has definition. Instantiate template name. Parse instantiate. Parse instantiate. Right. So yeah. So now when we parse the instantiate, what we need to do is the template name. This is the template, which previously needed to be the identifier, but now it can be any expression that I should evaluate at, let's for now evaluate it at compile time, and this should be a value of a template type, I guess. Yeah, so yeah, which also means that we have another thing which a value can be, right? A value can also be a template, which also means that I need to move the definition of what a template is from there to here. Cannot find AST in scope. Right, this thing actually depends on the AST now. Common. Compare template args. That also goes here now. Compare type. Okay, so once again, when we parse instantiate, I need the template itself. So the template itself must be a value, which is the template, right? So we say over here, evaluate. So the template is the AST in this case, right? And then we evaluate AST template, right? Which is going to be a value, right? And we say value expect the template, right? Span is template span. And this is not a template name, but just a template. Okay, let's start by expect template. There's like this weird thing about the ownership. We don't really like care about this right now because we are transplanting to JavaScript. But eventually I'll need to figure out the proper like over here, for example, I'm copying the type. Jack.
Hello Jack underscores I underscore.
Hello Jack Zai. Let's just for now say that value is like this, and this should return a template, right? So we just match self shape, and if this is a template, then we return template t, return t. Anything else? Panic. I also need a span, right? Let's see. So we have the error in the compile. Is this a compiler error? I don't know. It doesn't like really matter what I say here, but yeah, let's say that it's a compiler error. Expected a template. What did I get though? Is another question, right? But let's make a better error message. I mean, maybe I should just do it immediately here. Expect a template, but got well, I guess I can print the type of it, right? Do we have it's a little weird. Maybe if I move this block over here, actually. Giancaletito, hello, hello. And that would work because now I can use the print to print the type name, I guess, is what I print. So we say print type name of the of a self type, I guess. That's all. A diagnostic. Now this needs to depend on the diagnostics. Template is not unit. Output is not in scope. Output. Span. Okay, so now eval AST is not found because I never said what an eval is. Eval. I think I want to have something like, you know, current interpreter. Similar to how I'm doing the current compiler sometimes. Right? Yeah. Interpreter. Fine, let's take context here is context of the interpreter. Instead, I'm just going to import the interpreter from here, I guess, right? So dot interpreter lib. It's not a counter interpreter context. A little longer, but that's fine. And eval AST. No, I don't like that. I would just say interpreter eval AST template. There we go. Because yeah, we're just going to have over here eval AST, right? We have AST and this should give me the value. Okay. Well, I mean, the interpreter, on the other hand, cannot just evaluate the AST, because before we can evaluate the AST, we need to compile it to the expression, right? Because that's what it is actually supposed to evaluate. So maybe eval AST is actually does not belong here. I'll just have evaluate expression, which is expression, and this gives me the value, right? So we're going to measure expression. And figure things out here. So what are the expressions that I'm going to have even? Right, and what is the important one, right? When I evaluate something at compile time, for now, all that I really care about is the reference to an existing variable, which technically means that I need to claim a place, which is the identifier. And the identifier, that would be like a reference to a binding, actually, not just a string. Right? So I need to claim place. In this case, I'm going to evaluate place. And I'm going to claim the place. Yeah, there we go. That's all. So we have evaluate place. Expression is place expression. This will give me a place. Place. I'm not sure yet what a place is in the interpreter, but it's a thing that stores a value technically. So we're just going to do that. If yeah, result match expression shape. Right, so I just care about the place expression, which is an identifier name. So over here I need to like look it up in the current scope. So we'll have the interpreter scope. Which we need to look up. Let's for now to do panic. To do look up interpreter lookup. Value. And then what does a claim mean, right? Claim. Yeah, so actually place is a thing which has a place state. So places can be either uninitialized, moved out, or storing the value. I don't remember what I was calling this before. Occupied place. Right, it's an occupied place which is occupied by a value, right? So the place has a state instead of always storing a value. So when I claim, I'm going to move the value out if it doesn't implement the copy, but we are not there at that point yet. So if I have a place that is going to give me a value, I'm just going to match place state, and if it is occupied with the value, then I just return the value. If I have uninitialized, then I need to report the error that it has been not been initialized yet. Report some diagnostics here. Place was never initialized. Place was moved out. Of or something. Already. What's the span of these errors that I should report though? It means when I claim, I need to know the span, right? Span to report the error properly. So yeah, I just say that span is expression span. Span. There we go. So they can report the errors. Can find span. Can find output. Can find diagnostic. Source does not include the interpreter, right? So when I'm doing the diagnostics, I have a new kind of a thing, so we have lexer, parser, compiler, and interpreter now. Place is not a reference to a place. Should this return a reference to a place? Should claim take the place? Okay, so still evaluate AST is not there, but I think this can be like over here. Let's say evaluate AST. That's going to be AST. When I evaluate the AST, I also want to tell it the expected type, right? So expected type is going to be an optional type. And the AST, this is going to give me the value. So the first thing that we need to do here is we need to compile it, which is called parse here, but it is actually compiling it to the intermediate representation. So we say current compiler parse expression expected type AST, and this is the expression, right? And then after that, we say current interpreter. Evaluate expression. And that's what I return. I don't even do that. I literally just say interpreter eval expression. So yes, and over here I just say evaluate AST template expect template option. Yeah, when I evaluate AST, this over here, I guess I don't say what the type is expected here. I mean, this is a compile time known thing, so yeah. But I will have a type for templates, I guess. Cannot find value in scope. Mutable reference is not template, instantiate template. Right, because, oh yeah, over here, this gives me the, yeah, it's weird, but how about we just take that as a reference there. Couldn't find instantiation in scope. This now all exists. In that namespace, something which I probably should just use. Yeah, also over here I'm calculating the template args. Yeah, so this is like the actual instantiation that's happening, right? So I was generating a new top level item, but now that is not what we do. I don't do the top level item. I don't add the top level item. That's not a thing. What is F? Oh, this setup contexts. I see. Yeah, no, that's not what we do. When I do instantiate, instantiation results in a value. So I literally just evaluate. We have yeah, so what we need to do is we need to like in order to instantiate a template, we have the definition, which is the AST, right? And I just need to compile that AST and evaluate it actually as a value. I literally just need to evaluate it. The AST and the type, the result type, I guess, is not something that we know. I mean, at the place of the instantiation, I do know it, but it would be weird to infer it based on that. So this is the instantiation, right? Instantiation. Instantiation to expression. Maybe it would be easier if I started from scratch. Like, if I didn't have the templates yet, that would be easier. I don't have a lot of things, so maybe it's fine. I guess it's just the templates. Template name. Okay, when I do instantiate, I do not need to generate the name anymore. I don't. At the same time, like, having the names in the generated like output and the generated C code is nice to understand what was happening. Because otherwise I would generate like value 1, 2, 3 and everything, which is not as nice. Let's get rid of this for now. Instantiating top level item. Set up contexts. Okay. Yeah, so like the arguments are the types in this case. Let's keep it the types, but technically the way we're going to resolve the types, they are still going to be basically they're going to be compile time known things. So when I do instantiate this, integrate a new scope in the well, yes, and that scope the parent of that is not the current scope, but the scope of the definition of the template. So the template is going to be similar to a closure. It's going to be capturing a scope, right? So I say with a scope context. Is it scope context? Scope context. Into parent locals found in parent. Scope. Parent is going to be some template captured scope. locals is going to be ord map new. And found in parent is just a function that is not doing anything. So we need to convert every argument into a local, right? With template args. This is just a list of types. Wait, what? No. No. Or not no. No. Yeah, because like we have the args, but we do know the argument names actually. Yeah, template arguments. Oh, we even have by name here technically. We even have the by name, but that's because of the previous implementation. I might not even need that. Template args. Yeah, template just has the argument names. There we go. And we are... Yeah, when I'm doing the instantiation already here, right? This is where I am saying that by name is that. Yeah. I mean, sure, let's keep it there. Let's just say that for name value is type in args by name, iterate, right? I need to add to the locals a new local. This is a map from a string to a local. In this case, the local is going to be a const, and the value, which is a type. And a value, which is a type. Value, new type. Let's do that. So we have a new kind. Yeah, because yeah, that's what I need. I do need to treat types as values already. So we have a new kind of a value, which is a type. Which also means that I will need a new type of a type, which is a type. Right? So we can say new type, and this gives me the value. This is going to be the shape is type, and type is type. Right. Type's type is not type. Oh, because types have shape. And what? Wait, what do types also have? Oh, types have shape and how they have optional alias name, right? So type has the shape, which is type, and alias name, which is none. Which is why I want this to be a constructor. Reference to that is needed. Scope context. Cannot find scope context in the current scope. This is a template. And template actually need the scope. Captured scope is not there. That is right. And this is where the recursiveness of everything tells me that I need to like move everything here now. Right? So we have a template which should know what is a compiler scope, basically, because we're capturing the template is capturing a compiler scope, right? And the compiler scope is this thing, which is defined over here. So I need to like move all of this definition over there. So this should be like compiler scope. We'll have bindings as first class values to compiler scope. Now let's make this a module, because we'll have like a local to the compiler scope and a local to the interpreter scope, which are different things. So this is the compiler scope specifically. Compiler option T. Compiler scope T then. No implementation of values as modules, of course. I kind of want to only have the definition here. I don't even need to call this IR anymore. Like, it's not even about the IR now. Use IR types star. There you go. Maybe later. Create context type, expected a type. Where? Over here, right, because this is not a type. We need compiler scope.t now. A local is going to be in compiler scope local type. Could not find local in scope. Compiler scope local. Couldn't find name. Okay, template. So we are continuing to instantiate the templates still. So I have initialized the scope, which contains all of the template arguments as the locals. And now using that scope, I just need to evaluate the AST. We don't know the resulting type, but the template definition just needs to be evaluated in this scope. And that is the result value, right? So we have the template instantiation, right, which has template, args, and result. Right, so template, args, and result. There we go. Which is a value. Field name is not there. Instantiation name. Instantiation. This is equal to that. Right. So now we can know what it instantiated into. Then I'm going to just get rid of this log. Okay, instantiation to expression. Because sometimes, what am I trying to do here? I'm trying to parse instantiation to expression, which is, because because we could instantiate and get as a result a type or a function. In which case the instantiation would be an expression. But now they are always instantiating to a value, and that value might happen to be the type instead. Well, I mean, if it is if it is to expression, all they need to do really is to say that, because I have a value, right? I have a value here. So that would be an expression which is a constant. So we actually have a new type of an expression now. Yeah, we need to have a new type of an expression, which is a constant. Right? Like right now, in terms of constants, we just have the literals, but we don't even need the literals anymore. We just need the any value as a constant, which would include the top, which would like be the top level functions too. And top level constants stored like that. Yeah. Let's skip the literal, but for now at least. But we should have a new kind of an expression, which is just a constant and a constant value. That's literally it. We just have the value inside there. So when I instantiation to expression, I just say that shape is a constant of a type instantiation result. That's the value, right? And the type of it is going to be instantiation result type, value type of this. Parsed expression shape is not. Yeah, I need to say that it is an expression which is a constant. Okay, field name is not there. Lookup type, instantiation to type, right? So now when we say instantiation to type, this means that the instantiation should have instantiated to a type, but we don't need to look up anything here, really. We don't even need to look anything up here. I just need to say value expect type instantiation result span. That's literally everything that I need to do. So similar to expecting a template, we're going to expect a type that's going to return a type. And if this is a type, then I return the type. Otherwise, we say expected a type, but got something else, right? Okay. I'm going to keep this as a copy pasta for now. Hello, Elemental Magic. Hello, hello. How are you doing? Right, so now I need the captured scope here. And captured scope is going to be the current scope context. That is all, right? Okay, it seems like the template is compiled. Now we have the context. Parse context type. Parse instantiate root. Dot name. Right, so now when I instantiate something, I don't have the names anymore, right? So we say context name, and that's not a thing. Parse context type returns string and the type, which is the name of the context. And the context type. It should instead, we should instead have, this also needs to be like a first class value, right? Context. Context type. Maybe. Because we just say parse instantiate result value expect context type, because we have the context type as a first class value too now, right? So the new kind of value that we need at compile time is a context type, where context type has the actual type there, and then the name is also there. Which, sure, we can make that be a string for now. I might want to like rename this too. So like what we're doing is a context type is technically a field in the implicit context object, right? And this is the field name, and this is the type of this name. But I've been calling this thing a context type previously. Well, I mean, because the fact that it's a field is technically an implementation detail. It doesn't have to be a field anywhere. Keep the current name. So I want to expect context type. Context type. Context type expected at context type. And let's add the type of the context type too. Okay. Expect context type. Span is est span. Okay. That's what I return. A context type. If it is a token. Wait, what? Hold on. I had a rule. Instantiate. You know what? When we say parse context type, all that this means is that I need to evaluate the AST to the type, which is the context type. And to evaluate this AST, we expect to have the context type there. And then we say value x, and then we say this value expect. Yeah. That is all. And all of this can go away. So, yeah. Next, semicolon here is necessary. Find context type by the name. That's not a thing, because if we have the context type like this, right, then we already have the type there, and this is unnecessary. We might be able to like simplify a lot of code too by turning this into the interpreter, but yeah. Find context type. Right, so for example, over here, right, I'm trying to figure out what is the oh, I'm trying to get like, oh, I see, hold on, it's like, yeah, find the context type. In this case, yeah, it should not work like that anymore, I guess. So in minicast we have, so I'm using like current foo, right, in cast usually, which we say something like foo is a context of type like int or whatever, right? And then we can access it by saying current foo. What is the current value of the foo, which is a field in the implicit context object. And in minicast we also can say context.foo, so like explicitly refer to this implicit object and then get the field named foo there, right? But in this case, like we have like this should be a first class label of the field in an object. So maybe the the syntax should also like maybe the syntax should also tell us that this is not a field named foo, but a field named whatever name is generated by this thing, by saying dot foo in parentheses. Maybe. Right? Because this means that this thing needs to evaluate to a label of a field, which is what this is, kind of. If I don't do it like that, then yeah. I think we can for now just get to do fields of context. Let's not do that yet. Let's do that later. Okay, so we need to figure out the type of a field of an object. So if an object type is... Oh, wait a second. Wait a second. We are storing the types completely differently now too. Because it is no longer enough for me to say that it is a named type, which is a type named whatever, because that was like referring to the top level type definition, but now the types are also not going to be top level anymore. Um, right? I'm starting to think that actually writing everything from scratch is going to be easier than modifying this. I can probably like take from this code, like for example, I mean, a lot of the code is going to be the same, but a lot of the code is different too. If I'm making this change, might as well just start from scratch, you know? It's just going to be easier that way. How much code do we have here? Let's take a look. Toki. So like in total, I have 15,000 lines of code in this repository, right? But I'm specifically interested in the minicast. So minicast is just 6,900 lines, right? Which is not that much. And technically we have like the backends, which is the C backend and JavaScript backend, which JavaScript is like broken right now. It only has 600 lines. It is almost all the C backend, which is 2,600 lines, right? So, which means that the useful code is just like 4,000 lines. I mean, some of these is AST helpers. Yes, let's see. I mean, yeah, it's just like the compiler, right? That's what I need, like, to rewrite the mini compiler. 3,000 lines of code. Plus the definition of the types, right? Which also was pretty small. It's not that much, 3,000 lines, yeah. The C backend is going to need to be changed, but not as much, I think. And we can get to it after I have a working interpreter to yeah. I mean, I wouldn't even need to rewrite all of that either. So what's the problem right now is that just we had a type which was a named type, right? And the named type would just be one of these things, an enum, a union, or a struct. So like, yeah, maybe we could just instead have anonymous ones, anonymous types, and these would be just aliases to those. And we have the alias name over here already. Yeah, it's just like we don't have the we store the definition of the type directly in the thing. No. Yeah. I mean, I can say that instead of a named type, it's like a custom type, basically, right? Because those are like built in. Right? And this is a custom type, which would be a type definition, basically. Which will turn this into a recursive data structure, and I need to compare them. Custom type. Custom type. Just this. I should not be supporting aliases here, though. Okay, this is complicated. This is all complicated. I thought I would be making more progress than I had done already. I'm going to think about these things instead of going on right now, and I'll just end for now. I'll think about it and how to approach it. Maybe I just start writing from scratch. Instead. Which it just like makes easier to think about just like the high level part instead of like all of these little details because of the many things that are already there. Wouldn't take long anyway. We'll be rewriting this thing over and over and over and over and over and over again 1,000 times. It's okay. So we're just going to go chill. Yeah, I think starting from scratch makes more sense because like I can get like low key ammo. Let's see. Well, they're playing Batman. Not sure if I'm interested in that. I'm just thinking also like if I should rewrite or not, but yeah, I should think about it off stream. Let's just go to T2. So yeah, thank you for watching. Didn't get anything done, but I understand more about what needs to be done now. Bye.